So I just got done talking about the urea cycle. Now would be an excellent time for an ornithine transcarbamylase deficiency, an OTC1 deficiency. What it is remember we just turned our nitrogen plus carbon dioxide, used some ATP to create a carbamoyl phosphate. That carbamoyl phosphate is going to combine with the ornithine in the urea cycle to form a citrulline. And that's by this enzyme, ornithine transcarbamylase. So what happens if we have a deficiency in this enzyme? Well, we're not going to be able to combine with ornithine, we're not going to create our citrulline, we're going to have an excess of this carbamoyl phosphate. And what happens with that excess of carbamoyl phosphate? Well, we're not able to get rid of our nitrogen in the urine. So instead, we're going to have a buildup of nitrogen, and we're going to have carbamoyl phosphate buildup. Where have we seen carbamoyl phosphate before? Well, in my video on pyrimidine synthesis, purine and pyrimidine synthesis, the carbamoyl phosphate is going to be needed to convert to orotic acid. And the orate is going to combine with a PRPP molecule, and these two will form a UMP. And that UMP is used to form the pyrimidines, the uracils, the cytosines, and the thiogens. So the pyrimidines are required. To get the pyrimidines, you need orotic acid. The orotic acid is going to come from your carbamoyl phosphate buildup. And if your ornithine transcarbamylase enzyme is deficient or not functioning correctly, you're going to have an excess carbamoyl phosphate. You're going to have an orotic acidemia in the blood because of this backup in the system. And then also you may have a pyrimidine excess. But one of the key findings for an ornithine transcarbamylase, you're not able to go through the urea cycle. You're not able to spit out that urea at the end. So your urine is going to have a decreased nitrogen content.